Hello, we have a simple mixed operations problem again today. It's a 1 plus 2 times 3 minus 4. Let's see if we can not have a sad face on this one. All right, if you'd like to pause the video at this point, you can. We will come back and work it out together. All right, so hopefully you recall your order of operations. This is some basic elementary school mathematics. All right, so when you look at a problem like this, you do look at to see, do we have any parentheses? If you're familiar with BODMAS, you'd be looking for brackets. Same concept. Um, we don't have any parentheses here. So what do? Do we ignore the order of operations? No, we don't. A lot of people mistakenly think you do, but that's never been true. Um, we would then look for exponents, and this is basically if you're following the acronym called PEMDAS. But now, when we say exponents, we're really talking about anything that is shorthand for repeated multiplication. So actually, that could include things like square roots or factorials. Those are all things that are basically shorthand for repeated multiplication. We don't have any of that stuff here, right? We don't have those. Um, so we don't have exponents. Does that mean we ignore the rest of the order of operations? No, we don't. We move on to step number 3, which is where we look for multiplication and division left to right. And just remember division, we don't have any here, but if we did, division is it's the same thing as multiplying by a reciprocal. So multiplication and division are given equal precedence. You just solve them left to right. Well, we do have multiplication here, so we are going to solve that first. We don't have any division. All right, so we know we're going to be doing the 2 times 3 first. What's next after that? Well, step number 4 is addition and subtraction. And you can say left to right, really, as long as you're not moving the operators around to different numbers. Addition and subtraction can really be solved in any order. It doesn't matter if I add the 1 or subtract the 4 first in this problem. Now, I hinted a little bit at this, but there are acronyms. These are some just memorization tools. They're really misunderstood by a lot of people. A lot of people will look at this list and say, well, look, they're all different. They all teach different things because PEMDAS has M before D and BODMAS and BEDMAS and BIDMAS all put division before multiplication. Well, that's the wrong way to look at these. These are just acronyms to help you try to remember the order of operations. They're not literal 6-step checklists. So when I say PEMDAS, the first step would be to look for parentheses. The second step, the E, represents exponents, but again, it's not just exponents. It could be factorials, it could be square roots. The M and the D actually have equal precedence. That's why PEMDAS, BODMAS, BEDMAS, BIDMAS all give you the same answer. Because with BODMAS, instead of saying parentheses, they use the word brackets. Instead of E for exponents, they use O for orders. Orders is somewhat generic, I think. It covers the exponents, the square roots, factorials. And then they have D before M, but it's really meaningless because it doesn't matter. You could write BOMDAS, and it would still be the same thing. And the A and the S, again, addition and subtraction have equal precedence. I have had people try to tell me that addition is solved before subtraction. Again, that's incorrect as well. But enough of that. Enough of the crazy acronyms that everybody messes up. We already decided that we need to do the multiplication first because of the order of operations. 2 times 3 is 6, right? 1 plus 6 is 7. 7 minus 4 is 3. Now, I already know there's a lot of people out there going, nope, back in my day it wasn't 3. There are a number of sad arguments that people make, and they make these pretty consistently online. People will say things like, well, there are no parentheses around the multiplication, so you just solve left to right. When I was in school, you didn't do the multiplication first unless you had parentheses around it. Well, guess what? Multiplication already has precedence over addition. If your teacher wanted you to draw parentheses around the multiplication, It was just to highlight the fact that it already has precedence. It doesn't magically give precedence to the multiplication. It already has precedence. And you can look up the definition of multiplication if you want to. I can simplify this definition for you and basically just tell you that multiplication literally is repeated addition. Parentheses are not required to give it precedence. You already need to solve that multiplication first. You either multiply or you convert that multiplication to equivalent addition. Either way, you need to take care of that before you add and subtract, unless that addition and subtraction is within parentheses. We're going to get into that. We're going to get into why you need parentheses to get the answer of 5. But there are some other sad arguments here. People will say things like, well, if we were supposed to multiply first, the multiplication would be written first. And usually this same group of people also will say, well, I read a sentence left to right. I should be doing my math problems left to right. Why would the multiplication be in the middle, or why is the multiplication on the end? If I was supposed to do that first, it should be written first. Well, that's not true either. It doesn't matter. The multiplication could be first. You still get the answer of 3 because multiplication has precedence over addition and subtraction, no matter where it's located in the equation or the expression. So again, here, these examples, this is the same thing as just written differently. Here we've moved the addition and subtraction around. We put the multiplication first. The answer is still 3. Again, it's kind of like when you have your groceries scanned at the checkout at the grocery store. It doesn't matter what order items are scanned. A cash register keeps a running total of items. You know, you've got the quantity of a particular product and the unit cost. It doesn't matter if the bread is scanned before the milk or the eggs are scanned before the apples. It doesn't matter. It's all going to add up to be the same as long as the prices and the quantities are the same. The order doesn't matter, but the multiplication still takes precedence. But you'll see a lot of people argue things like, well, when I went to school in the 1970s, the answer was 5, or the 1980s, the answer was 5, or the 1960s, the answer was 5, or 50s, or the 1940s, the answer was 5, or the 1930s. I've seen all these arguments, depending on the age of the person making the excuse, they'll pick whatever decade applies to them to make their excuse, and somehow that's supposed to work. But all you need to do is put down Facebook and open up a mathematics textbook. I'll just pick out a few of them over the last 100 or so years. This is from a 1922 textbook. So a parentheses expresses the fact that the quantities within the parentheses are to be taken as a group and to be treated as a single or individual quantity. 7 minus the quantity 2 plus 3 in parentheses means that the sum of 2 and 3 is to be subtracted from 7. This gives a remainder of 2. The same numbers without the parentheses, where we have 7 minus 2 plus 3, tell us that 2 is to be subtracted from 7 and that 3 is to be added. The result is 8. Notice how putting parentheses around the addition makes us do the addition first. If we don't have the parentheses, we get a completely different answer. So the other point being made is that multiplication and division signs take precedence of addition and subtraction signs. And you'll have to excuse me, the way the English is written here, it's a little different. But hopefully the point is still being made. The first two signs unite the numbers between which they are placed, as if they were in parentheses. So what they're trying to tell us is, and this is where I think a lot of older people are getting confused. They're thinking that you're being told here that multiplication and division signs already take precedence over addition and subtraction, but they make this point in here, which is what I think is confusing people, as if they were in parentheses. Now, parentheses are meant to highlight and give higher precedence, but they're also telling us that multiplication and division already have precedence. So here an example is division. 12 minus 10 divided by 2 indicates that 10 is to be divided by 2, and the quotient is to be subtracted from 12, which gives 7 as a result. So notice, the division takes precedence over the subtraction, even though the division was last. Then they go on to say, in like manner, 4 plus 6 times 3 indicates that 3 times 6 are to be added to 4, which gives 22. 6 times 3 act as if in a parentheses. So again, they're making this statement about as if in parentheses, which I think is what's confusing people. Too many people are interpreting that as meaning, oh, it doesn't have precedence unless it's in parentheses. And that's not what they're saying at all. They're already telling us that multiplication and division already has precedence. So I'm going to blame people's misinterpretation of what that means. I mean, here's a 1950s textbook. All right, so you've even got the description up here in this mathematics textbook saying parentheses and other symbols of inclusion are the customary means used to make clear the meaning of a numerical expression. However, mathematicians have agreed on a rule to fall back on if someone omits punctuation marks. This rule gives the order to be followed in performing the operations indicated in the expression, and the agreement implies, for example, that. And they use an example 5 plus 3 times 2. Guess what? The answer to that is 11 because you are um, solving the multiplication before the addition. And they're using color here for emphasis. But basically, it says here, in a numerical expression containing a series of numerals connected by symbols of inclusion, symbols of operation, you agree to follow this order. Number one, simplify the expression within each symbol of inclusion. And by symbol of inclusion, we're talking about parentheses or brackets. Number two, perform the multiplications and divisions in order from left to right. Number three, finally, do the additions and subtractions in order from left to right. 1950s textbook, very clear. 1913 textbook. This is from an algebra book, first year algebra, but it doesn't matter if it's algebra or not. The order of operations applies to algebraic and non-algebraic expressions and equations. So right here, it says the fundamental operations are addition, subtraction, multiplication, and division. Indicated operations are to be performed in the following order. First, all multiplications and divisions in their order from left to right, then all additions and subtractions from left to right. So there you have it. Pretty clear. There's some examples from 3 textbooks. There are no textbooks out there that taught anyone to solve blindly from left to right. One of the other big excuses I'll see is that people will say, well, guess what? My calculator told me the answer is 5, so I must be right. Well, here's some simple facts about calculators. Calculators basically are broken down in a couple of input methods. Basically, there's immediate execution mode, which is used a lot by little cheap dollar store calculators. Also, if you're using a Windows computer and you leave that calculator in what's called standard mode, um, it will immediately execute every operation as you enter it. It's really not meant to type in an entire mixed operations expression and then hit the equal sign. With a calculator like that, you would actually have to perform the 2 times 3 first, and then do your addition and subtraction to get the correct answer of 3. And what you'll see here is in both of these calculators, on the left here, I took that same computer calculator, switched it over to scientific mode, which you can do. You click on these 3 lines where they call it like a hamburger menu, and you can select scientific, you can select standard. In scientific mode, it works in what's known as expression mode. And you can see I typed the identical same thing in, even though it looks different on the right. On the left side, 1 plus 2 times 3 minus 4 equals 3. I typed the very same thing over here, even though the only thing left showing is the 9 minus 4. Because when I typed 1 plus 2, as soon as I hit the multiplication sign, it went ahead and added 1 and 2 and got 3. All right, and then when I typed the number 3, it took 3 times 3 and gave me 9. And then when I typed minus 4, it just left me with 9 minus 4 is 5. It's working in immediate execution mode. So it comes down to the two different input methods of calculators, and you need to understand that in order to know how to use your calculator correctly. So keep that in mind the next time you're working with a calculator, whether it's working in immediate execution mode versus expression mode. Your scientific calculators are going to work in expression mode. Um, and here's the other thing. You need parentheses to get 5. It's kind of ironic. All these people who claim that you just solve left to right and you don't have any parentheses and you're going to get 5. The truth is you need parentheses around the addition, 1 plus 2, in order to get the answer of 5. And here's your example, once again from a scientific calculator. 1 plus 2 in parentheses times 3 minus 4 will give you 5. Without those parentheses, you're going to get the answer of 3. And lastly, I want to talk a little bit more. I've already said this once. I said that multiplication is repeated addition. And again, you can replace that multiplication with equivalent addition, and you're still going to get 3 as the answer. We take 1 plus 2 times 3 minus 4. What's 2 times 3? 2 times 3 is the same thing as adding 2 3 times. 2 times 3 is the same as 2 plus 2 plus 2. So I can take this problem that we've got, and I can substitute the 2 times 3 with 2 plus 2 plus 2. What am I going to get as an answer? I'm still going to get 3. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 minus 4 is 3. It really doesn't get any simpler than this. So hopefully this has been helpful. If this has been helpful, please consider liking, sharing, subscribing, and I will see you in the next video.